All right, so we are going to be learning this semester all about the mills and milling operations. So this is going to be multiple parts as you go. The predominant aspects of ENGT 150 is learn how to set up and operate milling machines as well as the drill press. And that's what we're going to be concentrating on. So I'm going to kind of give a rough synopsis here of the milling machine before we actually start to make parts. Um, but let's talk first about safety. One of the reasons we start with the milling machine as opposed to the lathe is because they are, in some regards, a little bit safer. If you think about the lathe, we're turning the workpiece oftentimes at a rate of 2,000 to 3,000 RPM. If that workpiece comes out of the work holding method, it's free and spinning. In this case, on the mill, we're rotating cutting tools. And they rotate that faster as well, but the machines are more enclosed and just a little bit safer to use in some aspects. That doesn't mean that there aren't dangers associated with them, so we have to be aware of them. In the cutting process, we have to pay attention to the cutting forces. We're generating heat and hopefully getting heat away from the workpiece, and there's vibration there. All of these can cause issues as we machine parts. So you got to pay attention. You got to learn how to deal with force, heat, and vibration, and we got to know what we need to know in order to safely run and operate these machines. All right. So the main duty of the milling machine is to create flat surfaces and to create flat and square surfaces. These are very efficient machines for doing that. A skilled machinist can also set these machines up to cut angles, form radiuses or radii, bore holes, use attachments, make circles or parts of circles and helicals. Lots of different shapes that we can generate on these milling machines. Oftentimes those are either accomplished through the setup of the machine or through specialized cutters that you will get to know a little bit more as we proceed through the semester. And of course, if we're talking about going from the manual machines over to CNC control, it gets even more complex what we can actually do and generate with the CNC machine. Now, this class we will be using our CNC machines, but we're going to be using them in a manual mode just to kind of get you the idea of how these this process, the procedure to actually kind of create these parts. And here's just an example of what can be done on a CNC with CAD/CAM operations. All right, same thing with this, so I'll let you stop the video if you want to look at some of these. So let's start here with our standard skills goals. So by the end of this semester, you're going to know what all of these things are. You're going to know what the mill does in terms of face milling, step and pocketing, form cutting, boring, indexing, spacing, profile milling, angle cuts, drills and reams, arbor milling, rotary tools. We're going to have to go through all of that. So we're also going to talk a lot about how the actual mill works, both the vertical mill compared to the horizontal mill. We're going to talk about the differences between the manual milling machine that we have in the shop, or manual Bridgeport, or other manual mills in the CNC machine. So we're going to talk about all of these and get to know what the component parts and how the similarities from one type of milling machine to another are. We're going to talk about the different milling cutters. So now we cannot be all-encompassing in the variety of tools, but you're going to get the basics so that you have a understanding of what type of cutter is to be used and what setup and which situation. So we have to be aware of that. So we're also going to talk about later, towards the end, how to set up the machine safely, different ways to correctly clamp, work holding methods here as well, and you're going to get some practice doing a couple of different setups. For the most part at the beginning, all of our setups are going to be in a vise where we're more or less clamping a part between the jaws of a vise. All right, so here is another setup checklist. This will be coming later, so we'll go over what this 10-point checklist is. We'll go over calculating feed rates and speeds. So, and everything else that you would need to know, squaring up a part, what that actual process and procedure is. If you just have a raw piece of material and you need to machine basically a perfectly square block out of that. If you think about what we would refer to as a 1, 2, 3 block, there's a method to machining each side of that block to get it perfectly square and parallel within a couple of tenths. And you got to follow the correct procedure in order to do that. All right, so here's the basis right now, what we're going to get into. What does the mill actually do? Like we said, the milling machine is perfect for making sure that we get nice flat surfaces. So, and square corners. So the very first thing that you're going to use the mill to do is to machine a block and get it nice and square. Now, we're going to get a block in the process of this class. You're going to start to learn how to kind of look at and read some prints to get that idea there of what the print should actually look at and how you're going to read the print to make the part as well. Of course, the study of blueprints and print reading to make parts is much more elaborate, and as you go forward with your studies, some of you I know are either in the blueprint reading class or taking the drafting with AutoCAD class, so you will also learn more about that blueprint reading procedure in those classes as you take those as well. All right, operation 1. So there are multiple operations that we need to be aware of in the using the milling machine. So the first operation, of course, is face milling. One of my favorite things to do on a mill. So we talk about cutting a flat surface on the workpiece side that faces a spindle. So, and a face mill is a large cutter with cutting teeth. So there are several different types of face mills. We'll talk about those, so you'll be able to identify them as we go. As we look at face milling, you got to consider your workpiece feed direction. You got to consider your spindle RPM. You got to consider the what we call a depth of cut and radial engagement. We'll talk about what you need to know in terms of radial engagement and depth of cut with these face mills. Operation 2 is peripheral cutting or profiling. Some of you are familiar with this too, where we cut the side of the workpiece using the teeth of an end mill. We could also use what referred to as a face mill or a shell mill, but we get these profile cuts basically going around the outer edges. So that would be kind of considered peripheral milling or profiling. We also talk about machining steps or slots and pocket milling. So you got to be aware of that terminology. So if we've got like a inside of a part that needs to be machined out, that's what we would call a pocket. And there's a specific way that we have to kind of control the cutter to move down into the part and remove and cut that material out. So, or if we're talking about just steps on the side, that is what they call them. If you've got a shoulder, sometimes the step is also referred to as a shoulder cut. So you have to kind of be aware of some of this terminology here as we look at it, kind of equate and relate what we see on a print to what we're doing on the actual machine. All right, in reality, most of these cuts are combinations. Even if we're face milling, there is still a part of that is just kind of side milling at the moment as it's going through. So keep that in mind. So a lot of this is terminology, and we need to be aware of the terminology and how it relates to the cutting tool that we're using and the decision to use one type of cutting tool over another. So as we get into whether we're using a face mill or what oftentimes is called an inserted mill or an actual high-speed or carbide end mill, we basically, if we're starting a pocket, we have to get to depth somehow. And generally we refer to that as plunging to depth. Now, Before, when this used to be done, oftentimes we would drill out a hole first, um, and then we would go in with an end mill to cut. Nowadays, we can also plunge to depth using what we call a ramp move, where we start up above the part and we kind of ramp down in the Z as we go. Now, that is accomplished very easily on the CNC machine. On the manual machines, when we're doing on this on the manual machines, it is not as easy to do that. So we really have to be much more careful. And sometimes it's still a very efficient method to just drill your hole first and then go from there. When we do plunge, you got to notice and you got to pay attention to notice one of these end mills is center cutting. The other is not. So if it is not a center cutting end mill, you cannot plunge cut. You will either destroy the tools, damage the machine, or something will happen there if you try to plunge cut with a non-center cutting end mill. So make sure that you know and are paying attention to the end mill and whether it is a center cutting end mill like this one or a non-center cutting end mill like this one. So, of course, once you advance into CNC and programming, if you get involved into the CAD CAM side of things, the CAD programs oftentimes do this for us. And this is just an example of how it kind of creates a toolpath and verifies these pocketing routines. All right, we're going to stop right here at operation 5 and come back to that at a later date. For right now, you've got enough information for us to begin cutting on the machine and machining our block.